My name is Varun. I'm part of the EasyQ Solutions team. Basically, as part of our company, we help startups predominantly and other company and other medical device companies to get through their compliance requirements, right? QMS regulatory journeys. As part of that effort, um, today we thought of sharing what we have learned what I have learned over the last 15 years, which is one of the most important requirements of maintaining a risk management, right? And risk management focused on software as a medical device, right? Nowadays, software has become an integral part of pretty much every medical device that we see out there, right? So we thought of sharing what we have learned over the last 15 years with all of you all, and hope that this knowledge sharing session can help you in one way or the other, right? Quick introduction. My name is Varun. I have more than 15 years of experience in medical device industry. I started as a electronics engineer. Then I did my master's in biomedical. Over the last 15 years, I have worked with more than uh, 15, 20 companies, helping them get their ISO 13485 C certification, US FDA registration. I'm a lead auditor for 13485. I have a project management certification, and I am also certified for reliability engineering, right? In today's session, what we'll be focusing on is to try and understand, keep it simple, try and understand, what is medical device, what is risk management, what it takes to conduct risk management for a software as a medical device company, right? So this has been, for me, this has been a buzzword for the last 3 4 years, right? Where everybody comes to me, and the software as a medical device term itself has got different ways of pronouncing also, right? Somebody calls it SaMD, somebody calls it SaMD, right? The short form of software as a medical device, right? But what it is, what it really means, what is software as a medical device, how do we go about it, right? What different examples are there which needs to be considered as software as a medical device? We will start with that, and then from there we look at the approach that we need to take to conduct an effective risk management for a product which is deemed as software as a medical device, right? Okay, as part of this session, what I would request people would be is, if we can go through the session. There were a few questions that people who have registered for the webinar had asked, so we will go through those questions as well. And then if we have time, we will interact, and if there are any additional questions, we will take it at the end, right? If not, for whatever reason, if there is not much of time left, then please don't worry. We can always connect over LinkedIn. I can, you can reach out to me, and we can have a more detailed discussion as well, right? For today's agenda, we will start with first understanding, what are the different software related to medical devices, right? There are a couple of them. We will look into them. Then we will see some examples of SaMD, right? Then we will also look at what we also call it as clinical decision support software, right? CDSS. This is a term also very widely used if your target market is the US, right? So we look into that. Then eventually we will go towards the risk management process, some standard guidances that you should keep in mind for software as a medical device company, as a software as a medical device product, and we'll take it from there, right? Okay. So software related to medical devices, there are primarily two different type of software, right? One is what we call as software in a medical device, and software as a medical device, right? What is software in a medical device? In the most simplest way, it is nothing but your firmware, right? The software which basically enables the motion of hardware or enables the functionality of a hardware, right, is what we call it as software in a medical device, right? Again, the most simple word is what do you call it as firmware, right? Wherein, what is software as a medical device? The software as a medical device, what you see on screen is the textbook definition, is basically the software which on its own can perform functions which is in line to clinical side of things, right? So it doesn't operate any hardware, it doesn't control any hardware. It on its own, based on the inputs that it receives, can churn that input, and come up with an output which can be used by doctors or any healthcare professionals for either diagnosis or aid in diagnosis or treatment planning or things like that, right? So please be very careful to understand this. It's important for you to know what is software in a medical device versus software as a medical device. There is one more type of software which I have not highlighted over here, just for you guys to keep in mind, is software that you use in the making of the medical device, right? Software we used in the manufacturing facility, right? In the making of the medical device, in testing of the medical device, right? That's also third type of software. Not typically controlled by your QMS system. Not something that you should worry from the medical device regulations perspective, right? It goes through your internal QMS systems, right? But these two are something that you should keep in mind. For our today's discussion, we will focus more on SaMD, software as a medical device. But before we dive more into the detail of SaMD, I just wanted to kind of share this with you guys as well. Okay. Some of the examples that you can keep in mind for SAMD, the classic would be your AI algorithms. Nowadays, you are also aware of companies which take your sugar level data, right? And then they help you to manage your diabetes through the phone app, right? There are multiple companies you might have seen on ads and stuff. Even those kind of phone applications, right, which is enabling to help you reduce or manage your diabetes kind of issues, right? Or even to help you manage your hypertension, right? Whatever the disease condition whatever the disease might be, right? Even those kind of applications are also seen as software as a medical device, right? Even those software which helps you to kind of, let's say, process a data or process some information. It gives you the output. That output you use to, let's say, define the dose levels of an X-ray or a CT MRI system, right? The software which basically does the analysis or does the calculation and gives you the output, right, can also be seen as a software as a medical device. Keep in mind here that software is not controlling the system. It is not software in a medical device. It's completely separate software. You feed some information to the software. It does the analysis, or it does the processing. It gives you the output. That output then goes into as an input to another software or to another system to then run the system, right? In this case, the first software becomes software as a medical device, right, which is helping you to get that information which needs to be fed into another system in order to enable the other system's operation, or to do certain other activities put into this to the next medical device, right? So these are a few examples that you can keep in mind to understand what is software as a medical device, right? As I mentioned, apart from SAMD, there is also one more keyword, which is CDSS, Clinical Decision Support Software, right? Which is heavily spoken in the US FDA side of things. There is also a good guidance document around CDSS, what is CDSS, what is not CDSS. We'll not go into too much of details of CDSS, but definitely one key thing that you should keep in mind is, so okay, the whole CDSS thing came into the picture is to kind of, in a way, ease the regulations on certain type of software, right? What we call it as non-device CDSS versus device CDSS, right? If you are a non-device CDSS, okay, if you claim or if you fall in the category of non-device CDSS, and what is non-device CDSS is nothing but what you see on screen, right? Four key points. You need to meet each one of them, not or and, right? So you need to meet each and every point that you see on the screen. If you meet all of those as part of your device definition, right, then you basically are non-device CDSS. If you're a non-device CDSS, you are basically exempted from any regulation that you need to comply with, right? From an FDA perspective, from a US FDA perspective. So keep this in mind. Please, again, do not mix. CDSS is something which is predominantly on the US FDA side. If you are a company which is into India or some other region, you need to still look into the regulatory requirements of those regions separately, right? This is a topic, this is a subject which again is in line with the overall SAMD discussion, and hence I thought to bring it up to you guys, just so that you guys are aware, if you're not, to what is CDSS, how do we go about it, if we are a non-device CDSS, what happens if we are a device CDSS, and it is nothing but what you follow for your medical devices, right? So you will be regulated. You need to go either through a 510K or a PMA based on your classification. Rest will follow from there, right? Okay. So now the whole risk management discussion for SAMD, right? So many times, in my own career, when I'm talking to companies, or we are working together on some of the regulatory submissions or discussions with the AI companies, right? It keeps coming, right? That, Varun, how do we go about for risk management for software. What do we think? What do we need to look into, right? Is it even applicable? At times I've been questioned on that side as well, right? So from an applicability perspective, absolutely yes, it's a medical device. So when you talk about risk management, it is by sorry when you when you talk about you being a medical device, by default risk management becomes one of the most important activities that you need to look into, you need to address, you need to have your proper frameworks defined, processes within your organization, and it needs to be carried out, and you need to have proper evidences maintained, right? For me, risk management has been one of the most important processes compared to any other processes that you might have within your organization, because the whole thought process for any regulatory body is what, right, is to ensure that whatever product comes into the market, right, is safe and it is doing what it is supposed to do, right? So the safety aspect is the most important aspect, right? And for me, risk management has not just been to ensure the product is safe, but it also helps you to define your products properly, come up with new requirements. It actually helps you to improve your product, right? Because you might have not thought about a lot of things while developing the product. Especially it happens with a lot of startups, right, when they're focused on developing the product. When you take two steps back and when you do your risk management activity, right, it also helps you to think on a lot of features that you would have probably not thought about during the course of your development, right? Because at that point in time, you're more focused towards getting the product working and putting it into the market, right? So while risk management is an activity to ensure that your product is safe and you have all the right controls, right? For me, it is also an activity to improve your product, to make sure that your product becomes better with time, and keep learning from the market, from what happens in the market, and keep improvising your product, right? Okay. So before we go into the actual process of risk management, one more key thing that you guys should be aware of is IMDRF, right, which is International Medical Device Regulators Forum, right? They come up with a lot of guidance documents, and a lot of their guidance document are something that regulators like FDA, the European Union, even India and few other countries will look up to form their own policies and guidance documents, right? So if you have time, I would strongly recommend for you guys to read on some of the IMDRF's guidance document on software clinical evaluation, software as a medical device, right? The classification, risk classification of devices. There are a few others as well, right? Talking about risk categorization. So in IMDRF divide or defines the risk categorization for SaMD into typically four classes, right? So it is one, two, three, four, right? But if you see on screen the table that is being presented, the risk classification is based on two key factors, right? One is at what state you are looking at, what disease state you are looking at. Are you looking at early stage cancer, or are you looking at stage 3 cancer, right? So what is the disease or the criticality of the disease when you will be intervening, or your product will be coming into the picture, right? And second is, once your product comes into the picture, what is the intention of your product? Is your product, the output of your product is supposed to help in treatment and diagnosis? Is the output of your product is going to help in driving a clinical management decision, right? Treatment planning kind of thing? Or is it just to inform the clinical management, right? It is just informing the doctor that, hey, there might be something, I'm just letting you know, rest you take care of it, right? Or it is giving information which I can consume to then define my treatment planning? Or I am, the information is to the level where directly I take the information and start, either giving treatment or doing operations or whatever I need to do, right? So it is taking input from these two key factors, right? One is, what is the state of health that you are looking at, right? What is the criticality of the health that you are looking at? And second is, from what is your final intent, right? What is your product's final intent? Is the intent to treat and diagnose, or it is to help in treatment planning, or it is towards just informing the end user or the doctors of the particular condition, right? So keeping these two things in mind, right, the IMDRF came up with the risk scoring, right? That what would be class 1 versus what would be class 4. Now, why is this important? Is for a simple reason. This acts as an input for manufacturers to then understand what would be the criticality of their product, right? Based on that, the rigor on the risk management should be accordingly defined, right? So it's an input that you can take to understand that, hey, my device is going to be a low risk device, or my device is going to be a high risk device, based on which I need to then define my risk management. I need to then accordingly put the rigor on my risk management and ensure that my controls are adequately defined, right? So that's how you kind of make use of these kind of risk categorization, which basically acts as an input for you to then carry out the activities within your risk management process. Okay, now, Um, key steps to risk management. What I've done is I've simplified the entire flow of the information. Right, I have not gone into too much of nitty gritty, but what you see on screen, if you kind of even follow that, that will ensure that your risk management process would be good enough to comply to any requirements. Right. Um, it starts with device definition. What is that? We look into that. Risk analysis, evaluation, controls, benefit risk analysis, production, post production monitoring, right? And it's not a one time activity, right? With risk management, what I have also seen many a time, right? Companies do risk management processes. They define the process, they implement the process, they get their company certified, and then basically that process is shelved, right? That's not how it works. It's a continuous process. It's a cycle that that keeps repeating, and that's the reason you have production and post production monitoring, right? From where you keep learning and you keep feeding back into your risk file, right? Into your overall process as well, right? When do you start? When do you start your risk management activity? Or it should be in the beginning? Should it be in the end? Should it be somewhere where I have completed my verification validation? The textbook definition says that you should start at the inception stage itself, right? When you guys are planning to create a product, when you guys are in the planning phase itself, right? That is when you should start your risk management activity, right? Very important that you start your risk management activity as early as possible, right? As I said, it is not only about risk management. For me, has not only been to ensure that the product is safe, but is also an activity which helps you to improve your product, right? So you want to start that activity as early as possible, and then take it, and then keep working on it. Also, you should not be stopping that activity. It should be something that should be done in a regular basis. One advice that I keep giving to companies is that you should, like how you have your change management boards, which happens maybe once in a month or once every 2 weeks, right? Or your sprint cycle plans, right? Which happens once in 3 weeks, right? Typically once in 3 weeks, right? Similarly, you should have your risk management board as well, right? At least meets, at least a good frequency would be once in a month. You guys should meet, a team should meet, they should look into your existing file, and they should discuss as to what they have learned new from the product that they have developed, that they have, sorry, deployed in the market, or from the competitors which are already there in the market, right? Okay, going forward, device definition, very 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 important for any kind of activity. Let me say that way, right? Not just risk management, but for any activity. Because if you do not define your device properly, you are not going to do the right job when you are doing your risk management, right? What do you mean by device definition, right? The device definition starts with what is the intended use of your device, right? Is your device, as we were talking in the previous slide, right? Is your device for treatment, for treatment planning, or just for information, right? What kind of clinical, what kind of clinical condition are you looking at? Are you looking at cancer, or are you looking at something related to eye, right? Is your device, who is supposed to use your device, right? So the intended user of your device, right? Is it going to be a layman, or is it going to be a professional, a doctor, or someone who is certified in certain specific activities, right? So intended use of your device, intended user, intended use environment, right? Intended patient population. These are your four key bare minimum requirements that you should define very properly in order to help understand your device definition, right? Yes, then there will be a lot of other things about technology and the principle of operation, all of that you can keep adding. But the bare minimum things to start with are these four things, right? Your intended use, intended user, intended patient population, and intended use environment, right? If you do not define these properly, then it'll be, then your overall risk management activity might not be as effective, right? And even if you think, the risk categorization that we were talking about a couple of slides ago is also in line, or it's also defined through these four activities. Even your product classification, right, for regulatory compliances is also dependent on your intent use, right? So for me, the intent use definition becomes the most important activity before you start any other process, right? I mean, whether it be risk management or whether it be even your submission related activities, right? So first thing, device definition. Let's ensure that we define our device in the right way, right? And then we take it from there. Next comes risk analysis, right? So risk analysis for me, I typically divide into four categories, right? For a software also, the four categories that you define, you divide your risk analysis is: first, you identify different hazards, right? What are hazards? Textbook definition: hazard is nothing but source of harm, right? But let's take some practical examples. So for a software, what are the different hazards? Your hazard can be cybersecurity. Your hazard can be that your software itself was not working, so software bugs, right? Your hazard can be usability. How come you not think about usability? Well, if you have a UI, if you have a user interface, and the definition of UI is actually not just something on software that you see, right? If your product gives final output as a report, right, which the doctor is going to look into, which he's going to use to gain some information, even that report that you print and give it to the doctor, right, is also something that you should think from a usability perspective, right? So your hazards can be your security, your software bugs, usability. It can be, your overall functionality of the software. It can be your privacy related aspect, right? So these are the different hazards you can think from your database, right? Database can be another hazard from an AI perspective, right? That if your databases were not properly segregated, if you do not, define your data properly, that can also lead to multiple risk from a overall risk management, from an overall risk perspective. So make sure that you understand your hazards, make sure that you have highlighted or you are aware of your hazards. From there you can take it forward, right? So first is, you understand the hazard, high level source of risk or high level source of harm, right? Next comes your foreseen hazardous situation, right? What are the different situation in which you may lead to some risk, right, or you may have some problem, right? These can be very simple, straightforward, right? It can be something as simple as that, your software did not work because there was a bug, right? Yes, absolutely, it can be a situation, right? It can be in the AI world. It can be where the databases were not properly maintained. It can be where you did not segregate the training and the testing data sets, right? It can be where you use the same data for training and testing, right? It can be even something where you have not implemented a good configuration management system, and again, your data were not properly maintained, right? It can be something where you have not defined the specifications for the phone on which the mobile application is supposed to work. Can also be something that you can think as a foreseeable hazardous situation, right? Keep it very simple, guys, from a software perspective, from the product perspective, and that's why, your product definition becomes very important. What all you guys can think in the most simplest way that can go wrong is what you should focus on. Many a times what I've seen is, when you talk about SaMD, right, and I'm going to be like honest, sharing my own personal experience with you guys so that it helps you, is many a times, the engineers or the folks who are doing this risk management activity, what they end up doing is, they will not focus on the simpler facts, right? The examples that I give you are the most simple examples that anybody can think of. They would rather go into the most complicated stuff, right? So don't do that. Don't directly dive into your architecture, right? First start with basic processes, basic things that can go wrong, due to which you can see some risk, right? So keep it simple. You keep your risk management simple. It will actually be more effective, right? So you define your hazards, you go towards understanding or identifying your hazardous situation. From there, for each hazardous situation, you then think about, okay, if this situation arises, what would be the output? That is basically, what would be the hazardous situation that you can see due to your due to your foreseen hazardous situation, right? So what risk will it lead to, right? So what are the different risks that you can think from a software perspective, right? Again, if you think about an AI kind of a product, right? It can lead to biases in the output, right? It can lead to software malfunction. Your software itself might not work. If there are bugs, right? It might lead to cyber attacks, right? You might have issues pertaining to cyber securities, right? And from there you then try to understand, okay, if there is a risk related to cybersecurity or cyber attacks, what would be the harm, right? Again, from a software perspective, the two key harms, or rather the three key harms that I have seen very common pretty much in all the type of software is either misdiagnosis, delay in diagnosis, or loss of confidentiality data, or breach in privacy, right? These are the three four harms that I typically see very common for any software product. Like, and even if you guys think these are the typical harms that that a software product can lead up to, it is not going to kill anybody until unless it is a software in a medical device which is actually operating the motion of a hardware, and if that corrupts, then it can lead to a much more fatal scenario, right? So typically for software as a medical device, if you guys can think on whatever different softwares that you might have been aware of, or have worked upon, these are the three four harm that you might think upon, right? That you might actually see. One more hazardous situation that I would like to focus, or I would like to point to you guys, which is very important, which very, very, very few people talk about, and which is also one of the most important requirement from a USFD perspective, is the aspect of usage of open source libraries, right? Which is also, the word is also soup as per 62304, which is software of unknown provenance, right? What is software of unknown provenance, for people who might not be aware of this term, is basically any software that is not being manufactured by you, and you are not aware of the manufacturer of that software, right? So nowadays, as you know, that people, in the world of chat gpt, you ask anything to chat gpt, and chat gpt spits out to you everything, right? You now don't even know who has written that code. It is this machine who is doing all this search and giving you a piece of code, which then you use as part of your product in one way or the other, right? So these kind of activities, right, these kind of things is what we call it as soup, right? Where you might be using a freely available open source library, which already does certain activities, which is defined or developed by someone, right? You are not the actual creator. And when you use such libraries, right, in your product, right, those libraries are really called soup items, right? um, Now there are certain soup items which are also in a way banned by some of the regulatory forums, right? Because they are known to be very vulnerable, right? They're vulnerable towards cyber attacks, right? So there are these organizations such as NIST, OWASP globally, which publishes certain vulnerability list of different or such libraries that you should look into, which will help you to understand that, if you're using a certain library, is it amongst those list of vulnerable libraries or not, and then try to avoid those usage of those libraries, right? So that kind of hazardous situation is something that I rarely see that people think about, but it's very, very important for you guys to ensure that you use, if you're using a soup item, firstly make sure that the soup item is not amongst the vulnerability list of soup items. Second, if you're using a soup item as part of your process, right, which is you need to ensure that the soup item is properly validated for its intended use for your product. It has been validated, tested, it goes through the entire round of your unit testing, integration testing, system testing, and even validation before you qualify it as part of your product, and then you release into the market, right? Also, for these soup items, ensure that you have good configuration management system to, again, all of this is going to help you to reduce the risk related to the soup item, right? So the controls over soup, or the risk related to the soup items, is also something that you guys should think about when you're doing your risk analysis, primarily for any SaMD companies. Okay, moving forward. Okay, so now you have, defined, or you have done your risk analysis. You understand your hazard. You understand your hazardous situation, or foreseen hazardous situation. You identified the different hazard, your risk, and from the risk, you basically identify your harm, right? That it may lead up to, right? Now, once you have done that, right, you typically gauge the, how do you evaluate? How do you say that, okay, what kind of risk is okay, or what kind of issues are okay versus what are not okay? So what you do is, as part of your risk plan, right, which you develop during your initiation stage, you also define the criteria for what is acceptable versus what is not acceptable. And this acceptance criteria is defined keeping two things in mind. One is your severity of harm, what level of harm the particular risk may lead up to, you look into that. So that is severity of harm. and second is your probability of occurrence, right? You look into the foreseen hazardous situation, right, that you might have defined, and you ask yourself, hey, you know what, how frequently can this happen, right? And you combine the two to then understand your final risk priority number, RPN as we call it, right, which is combination of severity of harm and probability of occurrence, and then you see, where it lies, right? So you can do this evaluation quantitatively, where you say that, hey, you know what, my severity, I will grade it from 1 to 5, where 1 is the least severe versus 5 is where, someone can die. Or you can do it qualitatively, right, where you say, okay, I will define my severity as, low, medium, high, or the amount of striations that you may want to define, right? But based on your severity of harm and your probability of occurrence, then you see where your risk falls into. You define certain acceptance criteria. If the risk does not fall into that acceptance criteria, right, then you implement your controls and you move from there, right? One very very important thing that I would like to highlight when you talk about risk evaluation for SAMD, right? So we talk about probability of occurrence. How do you gauge probability of occurrence for a software bug? How do you gauge a probability of occurrence for something that you don't have any data on, right? For cyber attacks, how do you gauge, when the cyber attacks is going to happen? Yeah, maybe cyber attacks, you can always look into the articles, and you can say, oh, in a year there are so many cyber attacks, and you can still somewhere try to find some approximation as to how frequently it may happen. But for bugs which are very random, right, which you cannot gauge, how do you come up with probability of occurrence, right? So you cannot, it is difficult for you to predict probability of occurrence for certain hazardous situations, right? And mostly the ones which involves issues pertaining to software bugs, right? In such a situation, in such a scenario, typically there are two ways in which you can handle this. One, as part of your probability of occurrence definition, you always give these kind of hazardous situation the highest probability, because you cannot gauge the probability. And if you cannot gauge the probability, then by default the probability of occurrence should be the highest, right? Which is basically one. In the definition of probability, the highest probability means nothing but one, right? So in your case, if you're having a table which says a one is least and five is highest probable, right, then you will have to give the rating of five when you cannot estimate the probability of occurrence, right? Or in many companies for SAMD, what they also do is that they say, hey, you know what, we will not look at probability of occurrence, we will only look at the severity of harm. So in their risk management file, there will be no table on probability of occurrence. They only look into the severity of harm. They try to reduce the severity of harm, as much as possible, or control the severity of harm as much as possible. And that's how they do their risk management activity, right? I've seen both the side of both the ways of doing risk management. Both are okay, both are acceptable, both are fine for your regulatory compliances or for your internal process definition also. There are some thought process on, one is better than other. But from a very practical perspective, right, if you don't want to go into too much of nitty-gritty, both the processes are good. If you tweak the first process, you are good. Or if you completely define a new process for assembly, where you say, hey, I will not look into the probability of occurrence, because gauging probability of occurrence for a software product is not easy. It's not possible. From that perspective also, you can have a process where you say, I will only focus on severity of harm, and my software risk hazard analysis will only focus on severity of harm, and putting controls around the same, right? Okay. So you have done your device definition, you have done your analysis, you have highlighted, you have identified different risks, you have evaluated those risks to understand, where they stand, whether they are in what category based on your acceptance criteria that you have defined, right? From there you go towards risk controls, right? Guys, keep one thing in mind, right? You can never make a risk zero. Okay. And this again, I speak from my practical experience rather than looking into any standard, is because what do you mean by making a risk zero is basically that means that the feature is no more available, right? As far as that feature is there, there will always be a remote chance of that feature not working or creating some sort of risk, right? Your probability of occurrence or your severity of harm might go low, but turning it into zero means that that particular feature itself doesn't exist, right? So from my experience, the risk control typically is only to help you to manage the risk, to reduce the risk, or to control the risk in a way that it should not further degrade, right? The risk control is all about to ensure that whatever risk you have identified, whatever analysis you have done, whatever evaluations you have done for particular risk, right? You ensure through your controls you don't allow them to degrade. So it should not happen that you come up with a risk, you estimate that the risk is medium, and then after a few months suddenly it degrades and it becomes like a high risk, right? That should not happen, right? That is where your risk control should come into the picture to ensure that a medium either stays in medium or it goes down to low, right? Ideal condition would be that it should be reduced as much as possible, right? So risk controls are to ensure that you do not your risk do not degrade further. The thought process should be to ensure that your risk do not degrade further, and to ensure that you have proper controls on all the different risks that you have identified, right? Now when you implement risk controls, right, when you implement risk controls, you follow the hierarchy which is defined as per 14971 2019 version, which is you always give priority to design controls, right? Controls via design, right? So if there is a risk which you can control via implementing changes in your design, right? Changes in your design can be changes to architecture, or implementing quality checks within your architecture. A very typical thing for AI companies, right? They have these within the architecture. They have these multiple quality checks that they implement to ensure that the data that they are consuming is of the right categories, of the right type, right? So that the algorithm can process the data accordingly, right? Or you implement controls via processes that you have within your organization, right? So one that we were talking about, soup, right? So you should have a process which says that, hey, any soup items that I use, I will validate those before it can be part of my product, and it goes in the overall product development activity, right? So through your processes you need to have your risk controls. And in the end, right, in the end, if you don't have anything that you can do through design controls, if you don't have anything that you can do through your process controls, then in the end you should think about your information for use, right? Information for use is not just user manual, okay? Information for use is also the warning message that you guys show on your software product, right? So many a times, very common that even in your phone, even in our phone, for some app you might be deleting the app will give you two to three times. It will ask you, hey, are you sure? Do you really want to delete it? Do you really want to leave us? All that, right? So those are also messages, those are warning messages. Similarly, for medical devices, for certain key critical activities, right? There might be certain pop-ups, certain cautions, certain warning messages that might be part of the product, right? Even those warning messages are nothing but part of IFU, the training that you might be giving, right, to the end users on how to use the product, also part of information for use, right? So any mode of information that you're giving to the end user to ensure that the end user uses the product in the correct manner is what is information for use, right? So whenever you think about controls, right, whenever you think about implementing controls, right, always give priority to design, then comes your process, and then comes your IFU. Yes, you can absolutely have multiple controls for a particular risk to ensure that you have put enough safeguards into the place to make sure that your risk does not degrade, or it doesn't impact in a negative way, right? In a more negative way. So to ensure that you have those controls, you can always you have the freedom to have multiple mitigations for the same risk. It is not that you should, if you have implemented a control by design, you don't have to worry about process and IFU. It's purely up to you. You can have control by design at the same time, process at the same time, IFU, right? But if there is a hierarchy that you have to follow, the hierarchy will always be first think about design, then process, then IFU, right? Please keep this in mind. Very important, especially when you are dealing with products which are of higher risk categorization, higher risk category. That is where all these things becomes more important. Okay. Okay. Now, as I said, right, that you typically cannot make your risk zero, right? If you make a risk zero, it's basically that that feature does not exist. So now, what happens? So you identify risk, you did your analysis, you identified a number of risks. Then you did your evaluation to understand what risks falls where, high, medium, low. Then you put your controls. After controls, some of the risk will remain where it is based on what kind of controls you have put. Some of the risk might reduce, and post control your RPN will change, right? Post control, your severity of harm and probability of occurrence will change, and you will have the final RPN, or you will have the final risk priority number that you'll have to look into. Now, based on that, right, based on your acceptance criteria, right, the ones which still do not meet your acceptance criteria, or which might still be in a little higher risk category, right, for them you do what we call as benefit risk analysis. What is a benefit risk analysis? In benefit risk analysis, you are supposed to explain why a particular feature is beneficial over the risk that you see, right? So you're supposed to explain that, hey, while I understand that there is a risk related to there is a risk where I might mess up in segregating, or I might not be doing proper segregation of data. There is a risk related to that. But having data, having training and testing sets, having them, having my algorithm tested on training and testing has its own advantages, and you need to explain those advantages, right? In, again, the most simplest way possible, right? The thought process over here is not that, when you give your benefit risk analysis, you need to do a complete set of research test and all that. You can, where applicable, you should, right? But it is more about you explaining that, how your particular feature or the overall advantage of the product, right, is such that it outweighs the particular risk that you might be highlighting, right? So your benefit risk analysis, you need to be focused on explaining, whatever the risk is, what kind of benefits you have on table that you are offering through your product, right, or that particular feature that you might be talking about versus the risk that you identify, right? Many a time people talk to me, or they ask me, Varun, to what level of information we are supposed to give? Are we supposed to do some additional testing? Are we supposed to do some third party testing? How do we ensure that we have done whatever is needed for the benefit risk analysis, for us to then talk about the benefit risk analysis, right? While the ideal situation would be, yes, that, if you can, please go ahead and do it, right? That's the ideal scenario, right? But then I also understand that from a practical perspective, it is very difficult for, for every risk needs to be, evaluated by a third party testing and all of that, right? So even if you look into the research publication, or, if there are any publication about your product that you might have seen, or about a particular feature that you might be aware of, right? You can make use of those publication as well. And typically the benefit risk analysis is nothing but a simple paragraph, or a simple, summary that you provide about that particular feature's advantages, or your product's advantages over the risk that you have highlighted, right? So it's a very simple text, simple English that you write about the particular feature's advantage, and that's pretty much it, right? That's the least that you should do, right? For you to not only address the requirements of regulatory side of things, but also, from your own as I said, internal activities also, it will be very helpful, right? While you can go ahead and do as many tests as you want, the least that is expected from you is to at least come up with a summary of in a short paragraph, or a couple of paragraph, which explains, what are the benefits of a particular feature or the product, right, over the risk that you see, right? So not a mandate for you to always keep doing third party testing and all of that. While if you have done, or if you have done your own validations also, right, that can also be something that you can use to define the advantages of your product, right? Very important, guys. Many a times I have personally seen risk files where the benefit risk analysis is not written in the right way, right? Where people just talk about, they just write a very simple blanket statement which says that the benefit of the risk outweighs, the benefit of the product outweighs the risk that has been identified. That's not good, right? That's not the right way, right? If you want examples, right, in 14971 2019 now, there is a 24971 which basically talks about how to implement 14971, right? There are some examples of how to conduct benefit risk analysis. There is one such example on, not on SaMD, but at least for you guys to understand the concept of benefit risk analysis, is on X-ray systems, right? So it is defined in a very simple paragraph which says that, yes, while we understand that the X-rays can lead into causing harm to your body, right? But the clinical advantages of X-rays are very important, especially to understand the fractures, and to fix the fractures, right? So from that perspective, the advantages of usage of X-rays in a controlled manner is good compared is more is high compared to the risk that it may possess a particular user, right? So the way it is written would be a good way for you guys to take it as an example, to understand how you can go about defining benefit risk analysis, right? Very, very important, guys. Please please put some time and thought when you are defining your benefit risk analysis. Do not use blanket statements, right? For different features, you need to talk about different benefit risk analysis. And if it is at product level, then you can definitely talk about your overall product's benefit risk analysis. Give references to the articles if you have any publications, if you might be aware of any, that will also strengthen your overall benefit risk analysis. Okay. Finally, production post production data. This is the point where your product is into the market and you are continuously learning. Yeah, right. You're not learning only from your product. You're learning from what is happening in the overall market, right? The recalls that might have happened, the 483s that might have happened, some news articles that you might have read about your product or a similar product, right? From where you can get inputs on different risks or even benefits or advantages of a particular feature, right? You need to learn those, you need to understand those, you need to continuously keep looking for that kind of data, which then goes back into your risk file. When your risk file gets updated, your risk file is not getting updated only to add new risk, it is getting updated to even modify the existing data that it has, right? To modify the existing risk that you might have identified, to modify the existing the severity and probability of occurrence rating that you might have given, right? All of that will keep. It's not a static document, right? It's a very active document. It's a document which is continuously getting updated, right? So when you're doing it in the right way, but obvious. So when you keep learning more and more about products, like your product, your technology, or a similar product technology, which from where you can adopt certain things, your risk file is but obvious supposed to undergo a lot of adaptation, a lot of changes, right? So from production post production data, you get that inputs and you ensure that your risk file is always updated, right? This is again one place where people do not do a good job, right? Where they miss out on ensuring that their risk files are maintained properly. My request again would be that make sure that you put proper emphasis on this, get proper data, and that's where having some proper continuous forums, right, within your organization at least once in a month will help you a lot to ensure that you maintain your risk files appropriately and you do it in the right way, right? And trust me, it will help you, right? It has helped me, I can tell you from my experience. It will help any company which does put some good emphasis on implementing risk management process. Okay. Some of the standards guidances that you should keep in mind. The three key one, I have missed one over here, but I'll tell you guys about that as well. One is the most important, the one which creates the framework for any medical devices risk management process is the 14971. The latest version is 2019. Then you need to look into for any software as a medical device company, right? For any software as a medical device company, as of today, the key the key standard that you should look into is IEC 62304. 2006 version is active. There is one more version, 2015, which is also active. Either one you can look into, and then that should absolutely be okay, right? These two form the basis of your overall processes for an SaMD company and for your risk management related activities as well. Then there is one more, which is IEC 82304, which is similar to 62304. The key difference between 62304 and 82304, if I have to simplify and tell you guys, is 82304 talks about the software validation part, which is actually not there in 62304. 62304 stops at system testing and then it talks about releases, right? Wherein 82304 talks about clinical validation or overall software validation before it can be released, right? So that's in the most simplified way, the key difference between the two standard. Look into 82304 as well. And then 80002 hyphen 1 to the 2009 version, which is basically guidance on the application of 14971 to medical device software, right? So how do you implement 14971 for a medical device, for a software as a medical device company, is where you can look into this particular standard. Has a lot of good examples, right? A lot of the guidances that have been written are also written taking examples from this standard. So if you guys need a little more information, more examples, right, as to how to go about things within your organization, 8002 would be a good standard to look at as well, right? One more thing you should keep in mind is when you do your regulatory submission, right? While 8002, 82304 are also standards that you can refer to, But from a regulatory submission perspective, from a compliance perspective, right, from an audit perspective, the two standards that will always be in question would be 14971 and 62304. So 14971 and 62304 should form the backbone of your overall processes and the company related activities that you might have planned, right? And then the remaining can be something that can be used as a supporting standard as well, right? So your auditors typically don't ask for 8002 and 82304 when they come for ISO 13485 audit or your MDR audit. These standards are not yet seen as in medical device auditing standards, right? So auditing standards still remains 14971 62304. So as far as you guys have at least taken care of that within your organization, you implement 14971 and 62304, you should be good to go. Okay, so as part of our overall, while we were planning this session, we reached out to all of you all, and some of you all had some good questions. So what I've done is I've put those questions on this, and I would like to discuss and share some thoughts on these questions that you see on screen, right? So the first question was, how do we identify hazard related to just software products that include AI or algorithms, right? So if you First of all, to identify hazard, I will always point towards you defining your device definition. You should always start with your device definition. If you are clear with your device definition, identification of hazard should not be a big deal. But if you're looking at examples that Varun, how do I can I get some examples? Where do I look into it? Right? Then 14971, which is not 14971, but 24971, which is nothing but the standard which tells how to implement 14971 with some examples and all. You can look at 24971 or you can look at 8002 to get some additional examples for you to understand what kind of hazards there might be with respect to AI or AI algorithms that you can consider, right? So that would be a good way for you to get some input. But again, if you know your device definition, right, you will automatically come up with hazards. How to structure benefit risk analysis? What should this write up at minimum contain? I think I was talking about this when we were at the slide of benefit risk analysis. So as I explained, your benefit risk analysis should be detailed enough in the simplest way that how the benefit of a particular feature within the product or the overall product is advantages, or it has the benefits, what kind of benefit it has over the risk that you are highlighting, right? And to do this, you can use references of existing publications or your own clinical studies that you might have done, or your own publications that you might have got for your organization. You can keep all of those as references. It's not a mandate, it's not a hardcore requirement that you need to always go and do testing and do a third party evaluation for you to do or explain the benefit risk analysis for a particular, when you're doing your risk management activity. So that's not a mandate. As far as you can explain this in the most simplest way with right references, you are good to go. Okay. The software product need clinical validation, and can the results of it be used? Absolutely yes, right? And that's the reason why 82304 came into the picture, right? Because there was a lot of debate on 62304 ending at system testing, right? And 62304 is for medical devices software lifecycle processes. 13485 is for medical devices coordinating element system. 13485 calls for design validation. 62304 is ending at system testing. It was not making sense, right? And that's where the 82304 came into the picture. You need to validate your software. Now the question is, how do you validate your software, right? Do you do clinical studies? Do you do simulated studies? Do you use databases? It's completely up to you, right? Based on the product that you may have, you can take the route of clinical validation. You can take a route of existing databases that are there nowadays for ECGs, right? There are so many databases that you can use internationally acclaimed databases that you can use to talk about the performance of your ECGs. And when I say these databases, these are actually biological databases, right? These are not made up databases. These are biological databases that can be used, fed into the algorithm, and then you can compare the output with the input to see whether they matched or not, right? So many companies even do that. Not always you need to do a clinical study, right? But yes, you need to do your validation. I wouldn't use the word clinical, but I'll say your product validation, and the results definitely can be used to mitigate, to show the mitigation for a particular risk or control for a particular risk. You can absolutely use that as well. As How to score software cybersecurity risk? Very good question. So you can either take the traditional approach that we were talking about, but if you talk about cybersecurity, right? In cybersecurity, we also do something called as threat modeling, right? In threat modeling, what we typically look into is it's similar. The thought process and concept is similar to probability of occurrence and severity of harm. Here, what we look into is that when you do a threat modeling, how vulnerable is your software. So we do some sort of a vulnerability rating or scoring, and then if that vulnerability gets exposed, or somebody tries to use that vulnerability against you, right, in a wrong way. If that vulnerability is getting exposed, what level of threat you might see, right, what harm that you might see. So the the language and the words might be different, where now I'm talking about vulnerability versus threat and threat modeling and all of that. But if you see the thought process, right, if I put it out in a chart, and if I show you different stages, right, it is very much in line with the traditional risk management approach that we were discussing about, right. There are different ways in which you can do scoring. There are different scoring patterns, scoring methods. For me, what has worked is the most simplest way. You define your assessment criteria, use that assessment criteria, define your acceptance criteria, move forward from there, right. So either for cybersecurity, you can have a separate threat modeling that you can do, or within your risk management, you input cybersecurity risk as well, and then you define your overall process such that you are following 14971, right. So either way is okay. What are the minimum doc required to submit to FDA to let them know that all cybersecurity risks? Very good question, and I'm glad this question has been asked. If you guys are not aware, then it is very important for you, if you're in the world of SaMD, right? If you're in a company or you're making SaMD products, uh, very recently FDA has published a guidance document on cybersecurity. It's if I'm not wrong, it's a 49-page document, a very detailed document compared to what they had before, right? So they already had a cybersecurity guidance document that was updated to what was recently. I think in the month of September they had published it, right? Please look into that. It has n number of requirements from a documentation perspective. It starts from you maintaining your bill of material, you doing your threat modeling, you defining a cybersecurity procedure, you having a cybersecurity maintenance plan. Before that guidance document came into the picture, as a thumb rule, as a good practice, I used to recommend people that when you do your VAPT testing, right, vulnerability and penetration testing, at least submit reports which are at least not more than a year old, right, as a general principle. Now with the mandate of you submitting your cybersecurity maintenance plan, right, which is similar to your software maintenance plan, right, you will have to define the frequency in which you're going to do all these activities, right. So there is a series of documents, there is a list of documents that they have come up with. I mean, the FDA's guidance document has come up with a very good guidance document. Please look into that. It will give you the entire list of all the different documents that you should think about and define as part of your process if you are dealing with software, or if you're a CMD related organization, right. So thank you so much for asking these questions. I hope this was helpful. As part of our efforts, the intent is always going to be to come up with more such webinars. This is the first of our webinars, so we would like to connect with you guys. Let us know, reach out to us, follow our page where we'll keep updating on topics. We'll keep having webinars. The idea is to help the companies, help all of you all to get as much as practical knowledge as possible, because some of these standards, when you read, they are written not in black and white, but they are written, everything is in pretty much gray, right. So decoding those standards can be difficult. Our intent is to help you guys with our own personal experiences that we have been through. We have a team which works on different topics, right. So we will continuously be having such webinars. We'll be having some talks with some of the industry leaders, some of the auditors, right, to help you understand what all different things from practical perspective you need to keep in mind, right. Our focus is to help you guys enable the your overall compliance journey, to help you get better understanding from a practical perspective. Yes, we will also keep the theory in mind. Without theory we cannot even do practical, right. So we will do that, but we would love to be in touch with you. Let us know if there is something that we can help you with, or if there is any question. Please feel free to reach out to me, write to me, connect with me on LinkedIn, and I would love to connect with you guys and talk more about it. Unfortunately, due to lack of time, I will not be able to take more questions, but I hope this was helpful. And as I said, please follow our page, please be in touch, and let us know if there is anything that you may want to talk to me in person. I would love to connect with you guys and talk more about it. Thank you so much for your time.